In our study of probability, we're going to start out learning how to count things, because counting is essential to understanding how to do probability. So let's define a few terms. A probability experiment is an action or a trial through which specific results are obtained. Something like tossing a coin or rolling a six-sided die or randomly choosing people from a list. Those are all probability experiments. Each probability experiment has a sample space or a set of possible outcomes. So for tossing a coin, the set of possible outcomes are getting heads or getting tails. For the rolling a six-sided dice, the possible set of outcomes, or the sample space, are the numbers 1, 2, 3, 4, 5, and 6. Now for the third one is a little more complicated because I'm randomly choosing two people from the list. And I named them Angelina, Belle, Cameron, and David, so we could use A, B, C, and D to represent the people. And I want to randomly choose two people. So what's my sample space? Well, I could choose Angelina and Belle. Or I could choose Angelina and Cameron, or I could choose Angelina and David. So I'm done with Angelina because she's been paired up with everybody. Then I could choose Belle and Cameron, or Belle and David. So Belle's been paired up with everybody now. Then I could choose Cameron and David. So that would account for all 6 possible ways that I could choose 2 people out of 4. So there are 6 different outcomes. Now, an event is defined as a subset of the sample space. So for an event, for tossing a coin, an event might be not rolling, it might be getting heads. So if I rolled getting heads, then my sample space would just be heads. Now for my next one, it might be getting an even number. Okay, so rolling an even number, in which case my possible outcomes, my event space here would be 2, 4, and 6. The first one's known as a simple event because there's just one possible way to get it. The second one is not a simple event because there's 3 possible ways for that event to occur. And then my third one is, what if I were getting, how many different ways could I get one male and one female? So I could have Angelina and Cameron, Angelina and David, or I could have Belle and Cameron and Belle and David. The only ones I wouldn't have would be when I had 2 females, Angelina and Belle, or 2 males, Cameron and David, together. So there'd be 4 possible ways to get this event to occur. Now, let's look at when we have a little bit more complicated sample space, a more complicated number of outcomes. So what if I do 2 different things? I toss a coin and I roll a die. Well, tossing a coin has 2 different outcomes. I could either get heads or I could get tails. Then, after I roll the die, then I could get 6 different numbers. And so I could pair heads up with 6 different numbers. So I could get heads with a 1, heads with a 2, with a 3, with a 4, with a 5, or with a 6. And the same thing with tails. Tails could pair up with 1, 2, 3, 4, 5, or 6. So when I name my sample space, it's kind of like when I did the Angelina, Belle, Cameron, David example. There's actually 2 things put together in my sample space. So I could have head 1, heads and 2, heads 3, heads 4, heads 5, heads 6, or tail 1, tail 2, tail 3, tail 4, tail 5, and tail 6. So you can see my sample space is expanding because I did one event and then another event after that. So now my sample space has a combination of those 2 events. Let's look at one that's even a little bit more involved, and then we'll show you that there's an easier way to do this. So let's say I'm giving a survey and I'm giving it to high school students and I'm asking these 3 questions. What is your year in school? So there's 4 possible outcomes for that question. Who brings you to school? Parent, student, or myself? Three possible outcomes. Do you have a job? Yes or no? 2 possible outcomes. And I want to know, what is the sample space of possible 3-question responses? So let's start out with the first question is what year you are in school. So we have 4 different outcomes for this first question. I could have freshman, sophomore, junior, senior. Now, after I've asked the first question, I'm asking the second question, who brings you to school? So I have 3 possible outcomes for that, for each of the people. So each one of them could be parent, student, myself. Parent, student, myself. So who's bringing you to school? Parent, another student, myself. So I'm going to put those 3 for each one of them. Now, after that, then we can break each of those down into 2 possible question responses for the third. So we've got a freshman whose parents brought them, and then we ask them the third question, do you have a job? And so we have yes or no. So for each one of these, I'm going to attach a yes and a no. So I will hum or something while I'm doing this because this will take a few minutes. What shall I hum? Twinkle, twinkle, little star, how I wonder what you are. Not sure if singing words is actually helpful. It's probably going to make me mess up. So I will just finish this up. Okay, there we go. Oh my gosh, that was not straight at all. Not straight at all. So what's my sample space? Well, my sample space is the combination of 3 different, of going through the branches. So let's say I start with the freshman, and I travel along this branch and find out their parent drove them, then I travel along this branch and yes, they have a job after school. So my first outcome would be freshman, parent, yes. Okay, then my second one is I'd go from freshman to parent to no. That would be my second outcome. Freshman, parent drove them, no, they don't have a job after school. And then I could continue going down other branches. Freshman, student drove me, yes. Freshman, student drove me, no, I don't have a job. Freshman, I drove myself, yes, I have a job. Freshman, I drove myself, no, I don't have a job. Chances are if I were to find how many people answered that question, I would probably find I would have no responses for that outcome because freshmen usually can't drive themselves. But anyway, I could continue to do like freshman, student drove them, yes. Freshman, student drove them, no, etc., etc. And I'm going to go all the way down to at the end, what would I have? I would have like senior, I drove myself, yes, I have a job. Senior, drove myself, yes, I have a job. Senior, drove myself, no, I don't have a job. Okay, those would be my last 2. So I could have a whole bunch of different ones that I could get. Now, how many different responses are there? Well, we just need to count how many branches we have that have each response. So there'd be one branch, freshman, FPY, FPN, FSY, FSN, FMY, FMN. So we can see there are 6 different responses that start with freshmen. There's also another 6 different responses that start with sophomores, another 6 for junior, and another 6 for senior. So altogether you can see we have 24 responses. We could also get those by just counting the number of ends of the branches that I have. So if we go from 4 branching into 3 branching into 2 more, at the end, there's 24 different yes, y's, and n's in that last. So we have 24 choices here. Up here we saw that we have 12. 6 different ways to pair up numbers with heads and 6 different numbers to pair up with tails. Now, you might think that was pretty tedious drawing that, and I would agree with you. That was pretty tedious drawing that tree diagram. Tree diagrams are really helpful for organizing and looking at how things occur. Usually once you get started with it, though, you can pretty much figure out, oh, I don't know that I need to draw the whole thing for each one because I pretty much see what's going to happen. And it turns out there is a shortcut to this process, and it's called the fundamental counting principle. The fundamental counting principle says that if one event has m possible outcomes and another event has n possible outcomes, then the number of ways that the events can occur in sequence, one after the other, is just m times n. You just multiply their number of outcomes to get the total number of outcomes. And you can extend this rule to any number of events. You can have multiple events happening one after the other. So let's look at our two examples. Tossing a coin. There were two possible ways to get two possible outcomes for tossing a coin. Rolling a die, 6 possible outcomes. Multiply them together, you get 12 altogether. The 3 questions, so we have the class or their year in school. There were 4 possible outcomes. Transportation to school, there were 3 possible outcomes for that. Job, 2 possible outcomes. Multiply them all together. 4 times 3 is 12, times 2 is 24. You can see how the tree diagram is just a picture of the fundamental counting principle. So once you know the fundamental counting principle, you don't always have to draw that tree diagram, or maybe you'll draw a part of it and kind of see what's going on and then go, oh yeah, I know exactly what I need to do to count the total number of outcomes. Next video, then we'll talk about how we can apply this fundamental counting principle to some more interesting problems besides dice and coins.